3.
Okay, welcome. So today we're going to be working with triangles. Not just triangles, just the right kind. These right kind. It's the right kind because it's got the right angle. All right, we'll work on that. But the problem with right triangles, there's only a certain number of trios or a certain number of sides where all the numbers on the sides are nice and even. We call those Pythagorean triplets. But for all of the other triangles that don't have sides that are Pythagorean triplets, we have radicals, okay? So if they're not perfect, then they have radicals. That is a good metaphor for life, but we're not going to go there. We're going to start here with this triangle here. This side has, both of these sides are 1 in length, and this side has a length of the square root of 2. So to kind of give you an understanding of where that square root or the radical comes from, we always have to go back to the Pythagorean theorem, okay? The Pythagorean theorem, which I kind of covered in a different video, essentially just tells me the relationship between these two sides that touch the 90-degree angle and this hypotenuse side that is across from the 90-degree angle. If I square both of these and add them together, it should be the square of this third side, okay? And that's what I did. I took 2 and 3 and I substituted it in, and I got 4 and 9 when I squared them, and when I added them, I get 13. But that's not the final answer. That is still missing this piece right here. C squared is equal to 13. So this side right here, if I took that length and I squared it, that would get me 13. So I need to know what two numbers, C times C, equals 13. And it has to be the same number. I'm not going to go into explaining where the radical comes from, but I will go into explaining that in order to undo squaring a number, I'm going to take the square root of that number. Okay, so that's where we get the square root of 13 is equal to C. And we were able to undo that squared. Okay, so we have square roots, we have radicals. Well, not all radicals are pretty. Okay, and it's going to hurt some mathematician out there. Yes, this is plus or minus the square root of 13. And I'll get into that at another time. That's not for right here. And because this side is going to be positive, we know that's the positive square root of 13. So I'm not going to write positive, negative on both of these. I'm just going to write the positive in case that bothers somebody. Let's look at this particular triangle. Okay, I've already plugged it into Pythagorean theorem. I've already got over here to my answer, and you can pause and take a look at what the math is and how that works. I really want to get into what happens when I take the square root of both sides of these. Okay, what happens when I take the square root of both sides of my expression? And this will cancel out. This leaves me with just the answer B. And this leaves me with some weird radical number. We need to be able to simplify that. And that is the purpose of this video. And I have to have that explanation so that you know where we're coming from. Why am I doing this? Why is this skill important? So let's break this down. I'll do a couple examples. This might take a minute, so let's try this. So I'm just going to bring this up here, and that's where we're going to start, okay? So we're going to start with B is equal to the square root of 180, all right? We need to simplify this. The way we simplify it, you have to break up the factors of 180. So we're going to go back to 4th grade, 5th grade when you're looking at greatest common factors. We're going to go back to 6th grade when we're doing prime factorization, and we're going to break this up. All right, and if you don't know how to look at a number and instantly say what numbers multiply to get me that takes time and practice. So practice, take your time and do it. So right away I know 2 times 90 would work. I also know that 4 times 45 also works. We're going to do 4 times 45 for right now. I know 45 can be broken up into 5 times 9. I accidentally reordered those, but we know you can reorder numbers. That's okay. If this confuses you, I'll fix it, okay? I'll fix it. I'm sorry. Didn't mean to confuse you. All right, 5 times 9. 5 times 9 is 45, okay? Now, the way you simplify this is we're going to take the square root of each individual number, okay? All right? What two numbers that are identical multiply to get me 4? Well, 2. All right? 2 does. What two numbers multiply together to give me 5? nothing. 5, that stays exactly the way it is. It's a prime number, and I can't do that. But 9, 3 times 3 equals 9. So I can do times 3. All right? So now the numbers that are not in the radicals, I'm going to multiply together. 2 times 3 is 6. And the number inside the radical, I'm going to keep exactly the way it is. And that would be the length of that other side that we had there. Okay? So simplifying a radical goes, you've got to break up the number into its factors. And then you're taking the square root of each of them. Well, what if I did this a little different? What if instead, what if I did the square root of, and break 4 up, 2 times 2. And then I had 5, and then I did 9, 3 times 3. Well, the same goes here. The reason why I'm able to take the square root of 4 is because I know 2 times 2 equals 4. So, same deal here. I know 2 times 2 equals 4, so I'm going to take that out of the radical. And you'll have other teachers in other videos explain, well, it's a jailbreak. One of them makes it out and the other one dies. You know, and I got 2 2's in there, so you can do a jailbreak. But if you only got 1 5, you can't jailbreak because you don't have a partner. You know, 3's, same way. There's 2 3's. That tells me these 2 identical numbers multiply together to give me this right here. So I know I can take the square root of 3. But I can't do that to the 5. Okay? And so then I end up with exactly the same thing. All right? So that's just in a nutshell how you can simplify your radicals. Let's practice on a few, and so we'll go from there.